Hello and welcome back. Today I have one of the latest power supplies from iTECH. It is the IT-N6900 Series and it is probably one of the most beautiful power supplies I have had here in the lab. It is a high power supply, but also high precision, low noise and low ripple. So high power, yes, it is 1500 watts. This model here can go up to 60 volts, 25 amps, and you can use it fully. The high precision, it has an auto ranging readback, and the low noise, high ripple. How do they do that combined with the high power? Well, they smartly combined switching mode with linear technology. If you are not familiar with the brand iTECH, maybe you don't see it too much in home labs. They are actually very well known in the professional testing industry. Think of automotive, solar, battery testing. They have used battery testing systems, power supply, AC, DC, electronic loads, even AC. They have power meters and of course DC power supplies. Wow, look at that. It has this modern look, the black grays theme and the big screen. Buttons on the side, USB in the front, nice keypad for direct input. You have your V set, I set, output on off, exactly where you expect the buttons. You have the encoder and the push, but you can do exactly the same here. This is the IT-N6962, that means it can do 60 volt, 25 amps and 1500 watts. It seems a little deep, but of course we need to fit somehow 1500 watts in this device. We can compare it a little bit to a 6.5, 7.5 multimeters, because these are also always a little bit deeper. I have here a multimeter, and if we look at that, it is just a slight bit more. So if you can place one of these multimeters, it looks proper here. Lot of holes for the cooling, probably because it gets a little bit hot at 1500 watts. But also if you have a lot of holes, the ventilators don't need to spin that hard, because they can effectively move a lot of air. So I think that also reduces air if you have holes like this. So we can see that how that is in practice. And we have to look at the other side. Well, it's exactly the same here. A lot of holes for cooling. We can even see some of the heat sinks there. And again, a lot of coils that do a lot of filtering. What do we find in the back? It's quite complete. We have USB. We have the LAN connection. I think it's LXI compatible again. And we have here some digital in and out. You can trigger here. You have an inhibit. And here below the protector we have here another output, and here you can get all your full power out, and also with the sense wires. I have made some cables because I want to push it to the full limit. So these are these nice silicone cables. I think this is like 6 square. So we should be able to get the full 25 amps. And of course for the sense wires I have this. And then we can put the cover on later, and then it's all safe. Let's have a look at the layout. We have our voltage readout, our current readout. It's actually the setting. So if I want 10 volts, I set it to 10 volts, and it is the readback. So when I put the output on, we will see this is the readback. For the current is the same. We say I set. Let's say we want the current to be limited at 1 amp. Here we have it to 1 amp. And well, we have no load, so there is no readback. So we have direct entry. So if I want 13.8, just do this and we have it right there. But we can also use the cursor. If I set it here, we can go higher and higher. But it can also, with the outputs on, we can do the same. So we can just go low, low, lower. Then we have some information here. Here you see now it's green, but there are several protections that you have. You will see that in the top here. Here is the current range. It's now in auto mode, 25 amp. But you can set it manual to high, low. I set it to auto. There is an OVP, OCP, so over voltage protection, over current protection. You can even set the slew, how fast it needs to rise. We can set that here also. Let's go to the menu. Here we have the meter menu. We can set a recorder. The recorder is actually this screen. So here you can see exactly what you are doing. And the nice thing is it does it all at the same time. So if we go back to the main screen here, I set it to iSet. Let me set it to the voltage on. And now we can change the view. And if I keep it to iSet, I can just increase the voltage. And we can see the line go up. And if I go down, we can do it down. If you think, hey, I think I missed something, you just change the time base and then you can zoom out again. And then we can see it is slower. But meanwhile, if I push again this button, we can still change the voltage again. And then you think, okay, my time base needs to be faster again. You just click and you can zoom in or zoom out. So you can do it all at the same time. So this is pretty cool. You can set if you want to see the voltage only, or the current only, or the power only. And here you can set it also on and off. Well, this machine is full of protections. So if we go to the protection menu, here we can set the voltage limit, we can set the current and the power, but we can also set over voltage protection and the value, but also under voltage protection. You don't see this that often. The same for the current. We have the over current protection, but we also have under voltage protection. You can set warnings when it needs to kick in. There is a delay you can set. We can set power, also maximum power, over power protection, but there is some more. Here we have even fallback, and what you have with constant voltage, that they can drop the current, or when you have constant current, your load is too heavy, it starts to drop the voltage. Well, you can set here that you don't want it to drop the voltage, but it switches off the outputs. And that is the fallback. And you have also the inhibit set, that after it comes into the fallback, that you freeze the whole system, and then none of the buttons work anymore. But it is much more advanced. Here we have the config menu. If we go here, we can set all the defaults that we want when it starts up, but you can also set a priority. Let's say you set a constant voltage, but you also set a constant current. Where you want your priority, it is set to voltage. And that means now that it will try to do everything to not have overshoot on the voltage. If we set this to current, then the current has priority and it will not overshoot on the current. We can send some more here, the readback here, the measure speed. Can we do slower or faster? We have the slew rate up and down. Also we can set that. And we have a timer, it's not set, but you set the time there in seconds as well. We also have the system menu. We can set a beep of the keyboard, we can set the screen, we can set the trigger, and I think we can even somewhere set the source here if we want to do use the sense wires or not. We have the LAN settings and we have the information screen. And of course we also have the list programming. These kind of things, it's more easy usually with the PC, so I will try to show you that there. About the icons in the top, here it is just switch off. If I switch it on, it tells me, okay, you're in constant voltage mode. Well, we set also the priority to voltage. If I do the memory stick, it can find it here. And we can even do a screen print if we want. If I like this screen, well, probably you would like this screen. You think, okay, let me store this. We can just do a screen print. and it is saved. High precision, or is the readback any good? Well, let me try to find out here. On the meter, if we say we want 10 volts, I'm not using sense wire, so it could be a little different. It says here I set 10 volts, but then it comes back with 10,004. But the Keathley here agrees with that completely. If we do 20 volts, you see I also don't need to switch on and off while I set the voltage, which is nice. 30 volts, puff, it's there. We get the slight difference, and I go, well, I think I can go to 60 volts. 60 volts, look at that. Hey, we have a little readout. 6 microamps, look at that. We even can see the little micros, but where is that? Oh, that is exactly 10 mega ohms from the meter. Cool. I'm a little bit amazed that we can see 6 microamp on a power supply that can deliver 25 amps. So what I want to do now, it is low noise, low ripple. If I can measure that, I can of course not use my electronic loads because those probably have more noise than the power supply itself. So I will use just standard resistors, so that doesn't cause much noise. I will measure that with a shielded cable, and I will just compare it with a linear power supply to see if there is any difference. So I have it now connected to the linear power supply. I have my pure ohm float, and well, with the BNC connector it goes to the oscilloscope. But I'm picking up a lot of noise. It is really a lot. It is about 18 millivolts, but it is around a frequency of 50 megahertz. I have no idea where it comes from, but my lab is very noisy. So what I want to do is maybe that I do a low pass filter on it. Yeah, it's really weird because this is the linear power supply. If I take it out, it's even worse. But it should be low impedance because all these resistors are connected. So it is a little bit weird. Maybe it is my light here. Doesn't matter if I take this power supply or the other. So I need to filter out this signal. So I built a little low pass filter here. We can set it from 20 Hz to 20 kHz. And then at least we have these high frequencies of 50 MHz. I really have no clue where it comes from. But it is in the air here. This is better. We can adjust it a little bit. I see still 15 MHz. Can go a little bit lower like this, not too much, because of course I want to measure noise later. So okay, this is then the floor for the linear, about 2 millivolts. Let's try that first with the linear one. 10 volts, set to 5 amp max. I have only a few ohms, so maybe 1-2 amps. Let's see. Okay, 1 amp. Then I put the load again, 1 amp, and it comes down and it is still around 1.5. Do now with 2 amps, I still see 1.5. We do with 3 amps, I see still 1.5. And here it stays all around this 1.5. So let's do that again. I switch on the load. It comes back. We see 1.4, 1.5. I go to 2 amps, 3 amps, 4 amps. Let's do exactly the same here. This one also has the default width, which is good. Voltage set, same, 10 volts. I set, let's set it to 25. I don't mind just full power. And back to voltage. And let's see the scope. Let's go to 1 amp. Yeah, we see indeed there is slightly more. Instead of 1.5 we go to around 2 millivolt. Then we go to 2 amps. Doesn't change, stay around this 2. 3 amps and 4 amps. Let's see how the constant current will react. If I set here the current, let's say to 3 amps. So switch it on, 1 amp, 2 amps, 3 amps. Now I go to 4 and then it will go into CC. So this is on the linear power supply and you can see it is trying to adjust the voltage so the current stays within the line, but it does that. Yeah, quite noisy actually. Let's do the same here. I need to set the current to 3 amps. Okay. So when I switch it on, 1 amp, 2, 3, and now it hits the limit. 1 amp, 2 amp, 3 amp, 4 amp, but it is actually in the limit. And you see it does that a lot cleaner than the other power supply. It is even lower because it comes back to 1.5, 1.6. So that was actually quite interesting to see the modern linear here, or the modern switch mode / linear. It seems that the baseline of the linear was a little bit lower, like 1.5 millivolt, while this one was 2 millivolt peak, and it's still not that much of noise. But we could see that the quality of the constant current regulation was a lot better on the iTECH than it was on the linear, because on the linear you could actually see it tries to regulate the voltage kind of so the low pass filter for 20 kilohertz was actually a very bad idea. I need to do the measurements between 2 Hz and 20 megahertz. So the thing I need to do is just get rid of my EMI. I need to do chokes, EMI filters, but for now I will just compare all the papers and come back to that, continue the testing. We talked about that the iTECH had this priority on the constant voltage. So what I want to do, I want to set a linear power supply here and also this one, and maybe with the normal cables I can do the other one also. I like to see if I set it to 1 volt and I suddenly switch on the output, if it overshoots or not. I will just keep the load resistors on it just to that we sort of have a lower impedance, so maybe I pick up less noise. Let's see if I do 1 volt, and well, the current limit doesn't matter too much because all I want to do is just switch it on. I have it in single trigger mode, so, and we catch one. I save it. That looks nice. There is no overshoot, but there is a little thingy here. Let's try that again with the other. That looks different. We don't see any weird sparks. It looks very controlled. If we do the same with 10 volts on the linear supply, we don't see this jump, yeah, or this little jump is here below. That looks better. Let's do also 10 volts on the iTECH. Yeah, you can see the rise time is slower, but it looks a lot more controlled. We should also be able to do that right. So can we go a lot lower? It is now 30, 24. What is the lowest we can do? 654. I'm not now 1 millisecond. Does that actually change what we see? And is it still that controlled? Oh yeah, 1 millisecond is super fast. And then we see a slight jump. But let's compare this to the other power supply again, to see that it is really steep. I don't think this one will match that. Go back to single. Puff. You see, this one is then slower. So let's try 3 milliseconds. Puff. See how steep that is? And now we have no overshoot whatsoever. That was nice to see. You can actually adjust the slew rate. If you set it too low, you can have a slight overshoot. But yeah, just don't set it that low because it is already a lot faster than any of the other linear power supplies. And by default, it was set to 30 milliseconds. But you can set it as low as 3 milliseconds we saw, and then you have no overshoot, and then it is already a lot faster. There are two power models, that is the 850 watts and the 1500 watts. I have the 1500 watts here, and in both models you have also two voltages. One is up to 60 volts and 25 amps, and the other is 150 volts up to 10 amps. But if you want the 1500 watt version, you need a line voltage of 230 volts. So when you have the 150 volts line voltage model, then you are limited to this 850. First I want to use the front terminals. It is limited to 10 amps, but they give you a little bit more space, and then it will go into the security. So we see how that works. And I made a little box here to get the full 25 amps from the back. I use this nice thick silicone cables, and with the sensing is now connected to those two, but I can switch it over. But I don't use the sense today. We're just gonna play with the big electronic load. I will be using the Codot here. That one is also 1500 watts, so we should be able to get it to the full power. So let's say current, just do full current of voltage. I actually want to use the full 60 volts. So we can do 600 watts here from the front end if it is limited to 10 amps. So let's see how far we can push it. It is a bit difficult to show them again at the same time. Here I have a maximum of 60 volt, 25 amps, but we are limited here in the front, so this cable should be enough for 10-12 amps. And here I have the electronic load, and I will just switch it on. I will focus here on the display here. So output on, 60 volts, and now we already have 230 millis. Here we see also how much power it is delivering. Now I will switch on the electronic load, so we should have then about 1 amp. And oh, it's exactly 1 amp even. Okay, and I will just turn it up. We should be able to do. You can hear the ventilator spinning a little bit faster. And we should be able to get to 10. And we see that the readback and what we set are now also closer together than it had no load at all. And I don't see any problem, so I will just continue. What will happen if we go above the 10 amps here? 12 amps. We are already at 660 watts. This is a lot. My electronic load makes a lot more noise. We are now already at 720 puff, and now it goes front over current protection. Yes, and it is also in inhibit mode because we can't switch it on and off. But I saw that we could look here, and if I change the time base, we can actually see what happened. Yeah, can we go further back? No, it was already in the end. And the scale maybe, yeah, here we went up, and then it all went off. It's nice that it is in memory, that you can change later the scale and still see everything. That's nice. Well, it is really in inhibit mode, so the only thing to get out of that is reboot it. So that's a good protection. You can see in the screen everything what happened, but you cannot do silly things again by switching it back on again. So that is good. Let's start again and use the back, because we want to use the full 1500. Well, 25 amp through this cable is maybe not the best you can do, but I will not do it too long. And the most noise that we hear was not the power supply, but it was actually my electronic load. Well, I will not be using the sense wire, so I will just switch the sense over to the big connector here. So we could have a little difference in the voltage that we measure. 60 volts, again the limit to 25 amps. This is just the resistance of my electronic load. I've set it again to 1 amp. And here we go. And now we should be able to go a lot higher. Let's go to 10 amps again. Like it is nothing. The cables are still okay. 600 watts we are pushing now. Let's go to 1200 watts. Because we should be able to go now higher without any... Yeah, look at that. We go higher, higher, higher. We're pushing now 1200 watts. But we should be able to 15. So I'm not sure. Because my electronic load also has a limit to 1500. Well, the power supply already lowered this ventilator, but the electronic load now goes completely crazy. It needs to dissipate all the heat of this 1500 watts. So wow, what a power. But let's come back to the Ripple. I compared some of the most popular power supplies with the Ripple, if it is a switch mode or if it's linear, and made a little list. So let's have a look. So I made a little list with the linear ones with switch modes, a few popular ones like the Unity and the Sigland, and some of these cheaper ham supplies. And I also have the more expensive powerful ham supplies. And we see here, of course, that the linears have the lowest ripple noise on paper. But of course, it is not only about a low ripple, it is also about power. And we see that the linear ones have, as an exchange for the low ripple, also have a very low power. So it seems kind of a trade-off. The more power, the more ripple you can get. So I sorted the table again, and I did it now on power. And if we then look at low ripple for switch modes, we have here that there's a ripple of 10 millivolt peak peak, and it's only 190. If we go a little bit higher, here the 15, we have here the Delta Electronica. It's also switch mode, 700 watts, only 15. And here we have our iTECH, I'm having here on the desk now, has 20, but it has twice the amount of power. So from 700 to 1500 we only go from 15 to 20, and wait, it is even twice the size. So this one is half the power, twice the size, to go from 20 to 15. And here we have a few that are those cheaper ham high power. They are 80 millivolts. It's a bit high. So what I want to do now, I want to do the power, the ripple, and the volume, the size of the device, and make a new list. I wrote down also the volume. So this is a 2 height unit, but it is only half width. So 2.5, that comes to 1. And what I did then, I have here the ripple that we have here, and I have the power here. So then I said, okay, let's do the ripple noise, divide that by the power, because the more power, and then we multiply that with the volume, and then we get a list like this. And then we see here that some power supply, well, that makes sense, no? These two weren't that good, but the size is also quite small, but they end up here in the end. While now the iTECH is all the way in the top, because for the switch mode, 20 millivolt peak is not that much, especially with 1500 watts in that small size, because it will always be a little bit of a trade-off. And why I think this is a fair comparison, it is because if you make the device twice as big and you put the second half all full of capacitors and filters, of course you get a little bit of a lower rumble. But there are some brands that say we don't want to do any compromise. You know what we do? We make it not even twice as big, we make it 4 times as big, then we make it linear and we put it full of capacitors. So I added a few more to the list, and that is here the Rode & Schwarz. It also delivers a lot of power, 1200 watts. It is still linear, but it is huge. It is 4 height units. But the noise is only 1 millivolt. So if we take that same theory and we divide it by the space it's using with the power it is using, it is actually pretty good. And then the iTECH here comes at the second place. So if you want something uncompromised, you look at this. Well, I said about the Rode & Schwarz that it is uncompromised because of the 1 millivolt and a lot of power. But have a look, it's here, it doesn't even fit on my desk. It is 4 times the size of a normal power supply here. And maybe it doesn't show that good on video, and it is like 1.5 times as deep. So that is also a compromise, something too big. And not only that, also I needed to build a slow starter to even get it started, because otherwise it would blow my fuses. Because imagine, it's full of capacitors. When you switch it on, all these capacitors are going to be charged, so it is a huge peak of current. Then coming back to the list, 20 millivolts on 1500 watts in this little package is then suddenly not that bad. And 20 millivolts, you need to ask yourself, is that even bad? Because if we have here these ham power supplies that sensitive HF radios can deal with the 80 millivolts, then yeah, 20 millivolts is a lot lower. And also, if you have sensitive amplifiers, you probably have some filtering inside of it anyway. So, well, I'm really impressed with this iTECH. It is the IT-N6962, in this case 1500 watts up to 60 volt, 25 amps. It's crazy, and I like how it looks. It just fits exactly here in my stack. It is not that big, it is really a small power pack. And also it's full of protections. You have your over voltage but also under voltage. I didn't test that yet. The fallback we have seen, also including the inhibit when we tried to take too much power from the front and everything was locked. Perfect protection as well. So the first thing I need to do now is get my filtering in order. I need to get rid of this interference I have here in the lab. So that was the iTECH IT-N6900 series. I hope you enjoyed that. Thank you for watching, and I hope to see you next time.